Well, we're gonna have a really short class today. We have 10 minutes left. But that's okay. I feel like making sure that we fully go over exam questions and understand them is very important. And we're also still in a pretty good place for specific content in the class, I think. So we talked about compilers in general. We talked about the overarching steps that compilers use in sequence. And then we talked about tokenizing in a bit more detail, the fact that you could use a DFA to represent token identification was a cool find in the middle of that. But the second step, actually, before we do that, let's just go back to that process overview so that we can visually see where we're going. We're doing this again. We're back at the parsing step now, where we have scanned for tokens. We know what those tokens are. We're passing a stream of tokens into the parser, and the goal of the parser is to construct that parse tree. So that's where we are in this process. So at this point, we have a grammar representing the language, and we are going to take this stream of tokens and see if the grammar can produce this stream of tokens. This is something that CYK can do for us. So as you're implementing CYK, you're implementing this portion of a compiler. But it would be ideal, since we know that CYK is cubic in complexity, it would be nicer if we had something that, depending on the grammar or depending on the string, something allowed us to do this faster than that at times. Because cubic is kind of slow. It's very possible, but it would be ideal if we could do this faster than that. But at a higher level, if that grammar can derive the stream of tokens via some application of its rules, then we can prove that it is syntactically correct in that language. As we go through this process, we're building that parse tree. If it is an unambiguous grammar, then given a stream of tokens that is in that language, there is a single parse tree that can be built for it. There are not multiple parse trees because it is not ambiguous. And so this process can only generate one possible parse tree for that program, which will help the next step. Yeah, when we map to a particular rule, then we make a new node in the parse tree as we construct that parse tree from the process of recognizing grammar productions. Yeah, if the program is syntactically correct, tree is also complete, representing the program, of course. We then send it on to the next step. But to give you an example parse, this is kind of what we've been doing a lot in the class, but tying this to the kinds of programs that you actually write. Every program has a main method made up of some number of statements, each of which must be either an assignment. This is an example grammar that is going to be significantly simplified. So we allow for assignments, prints, and that's it. As simple as it needs to be. So an example program would do something like this. We have very specific spacing requirements now for our tokenizing. And we're only going to allow, for the moment, the variables A and B. Go ahead and write a context-free grammar for this. And I'll give you some non-terminals that you might want to use in this. You can use program, sequence, line, variable, integer. And you also may need another one. Let's say you can use expression. So I'll add one to this. Wow, font has so much better handwriting than I do.
Again, assume there's no arguments. Should I put something between?
Yeah, there's no arguments to make. But the idea is that you can represent any value of this. no A's and B's. You don't need to further specify down to the very what the A's and B's actually are. We get something like this. We could further expand variable to be A or B, some rule for variables, but I just left it as variable for the moment. We say that a program is made up of the terminals, the token main, the token open parentheses, token close parentheses, and what follows is some number of lines that we are going to call a sequence. We can define that sequence as either a single line or a line recursively followed by some sequence, one or more lines. And then we have two options for what a line can represent. A variable, the terminal equals integer, and or the terminal print, the terminal open parentheses, an expression, and then the terminal close parentheses. And that means that we don't have to further specify what an expression is. We had that earlier in the class when we talked about an expression and used mathematical order of operations and defined that there. So now we could take that idea as an expression and kind of wrap a shell around that is a main program, allowing us to write some kind of procedural program. Thoughts on this or questions? I need to remember to actually put this expression back in the slide.
We're at three edits to the slides. This one.
Yeah. Let's see, do I wanna?
Actually,
Yeah.
sorry, I do have a question.
Yeah.
How do you define expression using this?
That would be much more complicated. We'd have to get into the weeds of, in this case, we could probably just allow for variable plus variable, or to be able to generate that variable minus variable, variable times variable, but that only allows for an expression to be one thing, then we need to incorporate all of the past expression rules.
Yeah, because I spent most of my time trying to figure out how I'm going to get the like the function name, have it do any function name.
Yeah. Yeah, that's fair. That's a very large weed to untangle. What is expression and how to represent it, but yeah. We are out of time, but we'll come back from this and work on building a parse tree, or assuming that we have this program, that is this main program that we have, how do we actually build a parse tree given something like this grammar? Get some experience with that. Finish up compilers, talking about these steps, and then we will do the deep dive into efficient parsing. and reveal your next programming project. So I have office hours starting now up in my office. If there's anything I can answer with regards to CYK, which is due today.
What I'm gonna be working on.
Yeah, let's crank that out. And I'm around to assist.
Get the wildlife parks together, it's just.